Okay, so loading the data into HDFS. Now, see, whenever if you want to start working with the Hadoop environment, the first thing is you need to load the data into HDFS. So once the data is available in HDFS, the users are able to process the data, right? So suppose you're writing a job in Hive, or you're writing a job in Peak, or you're writing a job in MapReduce. So first the thing is what? So the file should be you should make the file available in HDFS. Once the file is available in HDFS, you can use that file to process with a Hive or with a Peak or a MapReduce for the job. Okay, so we have different ways to load the data into HDFS. So one thing is you can use Hadoop file system shell commands to load the data into HDFS. Okay, the one thing we use Hadoop file system shell commands, where we can copy the files from local file system to HDFS file system. So this is one thing. And second one, we have dedicated components are there. One is Cube. We have the two components are available with the Scoop 1 and Scoop 2. Scoop 1 is a client side environment, Scoop 2 is a server side environment. So when we are discussing about the Scoop in chapter 3, we'll dig more deep into what is the Scoop 1 and Scoop 2. As of now, remember, Scoop is a component in Hadoop ecosystems, which is used to perform import and export the data between HDFS and RDBMS. Okay, and then you can use Flume. Flume is a component which is used to collect the data from storage network attached storages servers in AS. Right, so we'll configure a Flume agent and we'll specify the location to that agent to collect the data. So the agent resides in the server where the data is available. It will collect the data and it loads the data into HDFS. And then you can use the commands. Web HDFS is a protocol or is a file system. We have discussed in Hadoop file system, right? So there we have discussed about HDFS, HFTP, HSFTP, WebHDFS. So WebHDFS is one file system where we can copy a file from the one cluster to another cluster, one machine to another machine. Okay, and we have a command Hadoop distcp. Right, Hadoop distcp is a tool which copies a file from the between the cluster. Suppose you have a cluster 1 and cluster 2. So in the cluster 1, one name node is there, cluster 2 is another name node is there. If you want to copy a file from the cluster 1's name node to cluster 2's name node, so we can use the command Hadoop distcp, which is used to copy a file from the right one name node to another name node. Right, we can use Hadoop distcp is one way where we can load the data into HDFS. And you can use ACP, or you can configure FTP to transfer the files to the HDFS. Okay, so if you are using Hue is a component in that one. So we have an option file browser. So using that file browser, we can able to load the data into HDFS. Okay, the first thing is you can use Hadoop file system shell commands. So in the file system shell commands, we have the commands like Hadoop fs-put is one command. Next, see here, eighth one, you can use API. You can use Java API to read or write the files on HDFS. Right, so these are the different ways where we can able to write the data onto the HDFS. So the first thing is you can use Hadoop file system shell commands. Okay, so the commands what we have Hadoop fs-put is a command which copies a file from the local file system to HDFS file system. The same thing we have commands Hadoop fs-copy from local is one command which is used to copy a file from the local file system to HDFS file system, and the Hadoop fs-cp is one command. Hadoop fs-move from local. Okay, so these are the commands where the users will copy a file from the local file system to HDFS file system. See here, ls, right? So here I have a file city5.java. So you can copy this with the command Hadoop fs-copy from local. So what is the file name? It's the cities5.java. I want to copy this file to the HDFS directory, HDFS colon slash slash localhost colon 8020. Right, in the localhost I have a directory user, in the directory Cloudera and Ajay. Right, I want to copy the file cities5.java from the local file system, and I want to load this file system into the HDFS in the directory Ajay. So I run a command Hadoop fs-copy from local. Now cities5.java is copied from the local file system to HDFS file system. We can see here user Cloudera and in the directory Ajay, right, the file cities5.java is copied, right, 20th March 2015 as per the date. See here 20th March 717. Okay, now this cities5.java is copied into the HDFS file system. Okay, so next one, so we discuss Hadoop dist cp. Okay, so Hadoop dist cp is a tool, right? So dist cp is, you can call it as distributed copy, right? Which is used to copy the file from the between the clusters. You can able to copy a file from the name node one. Suppose we have one cluster, in the cluster 1, so we have a name node 1, so the name is name node 1. So in another cluster 2, in the cluster 2 we have a name node, the its name is nn2, right? So in the name node 1, in the directory user Cloudera, and in a directory Ajay, I have a file cities 5.java. Right, now I want to copy the file from the cluster 1, so name node 1 to cluster 2 name node 2. So we can use the command Hadoop distcp. Distcp stands for distributed copy, so which copies a file from the one name node to another name node. And see, the importance of this CP is, so it uses a MapReduce job. It creates a MapReduce job to copy a file from the one file system to another file system. We can specify the multiple file names as the source file name. So you can write Hadoop okay, dist cp, write the, you can write multiple source ones, source 1, source 2, then write the target, right? So the files from the source locations are copied to the destination target location. Okay, so we can specify any file system here. You can use HFTP along with the DCP. You can use SDFS along with the DCP, right? So which file system you are using, you can use any file system, HFTP, HSFTP, or SDFS file system, or you can take in input source as HFTP and the destination target is an SDFS, right? You can use this file system representations while specifying the URI. And remember, you must specify the absolute path. You need to specify the absolute URI to specify the location of the file's name. Okay, see here, I'm taking a terminal. So if you run the command hadoop dist cp, okay, see here hadoop dist cp, we have the options. So where you can use the options are for the replication number. If you want to specify the block size, use the parameter b block size, specify the username, group name with the p with the privileges, right? So you can use hadoop dist cp, right? It's like this hadoop dist cp hyphen p hyphen update. So here you already copy a one file from the one name node to another name node. Now so the contents of the a is updated, the bar is updated. So if you want to write this updated one into another name nodes file, then we use hadoop dist cp hyphen p update. Suppose, see here, now what I'm doing, see I have a file directory HDFS colon slash slash localhost colon 8020, right? In the directory Ajay is there, right? So here I have a file cities.java. Now I want to copy this file to another directory in another name node. Okay, so what I'll do, I'll write the command hadoop dist cp and specify the source location. So my source location is this one, right? Here I want to copy the file cities dot java to another name node. If you have two clusters, then write the another cluster name here, HDFS colon slash slash. So here I am using the localhost for everything, so I am writing HDFS colon slash slash localhost colon 8020, and I have a directory here cg. Right now I want to copy the file from the cities that from the Ajay to another directory Srijit using hadoop dist cp. Now when you run this command, the file cities.java is copied from the Ajay to Srijit, right? So here this cp uses a map radius to copy the files. So generally here I am using the same name node to copy the files, but in a real time the dist cp is more powerful if we have if you are able to copy the files between the clusters, right? You can able to copy the files between the clusters. Suppose you have a one cluster one and you have another cluster, so the clusters with a different version. Suppose see here, generally you have one cluster is available cdh3 you're running, and in another one you're running cdh4, right? Now if you want to copy a file from the cdh3 to cdh4, that is here two different versions are in one name node, one is running with version hadoop some version hadoop 1.0, and in another name node is running hadoop 2.0, right? Even we can able to copy the files between the two different versions of hadoop, right? In the name node one, in the one cluster, in cluster one, in the name node one, so we are using hadoop 1.0. You can copy the files, we can able to copy the files in another name nodes, another cluster between the two different versions are available, right? C1, in the C1 in the cluster 1, so the name node 1 is running the version hadoop 1.0. In the cluster 2 we have it's a name node 2, and name node 2 means what? It's another name to the name node, right? And right, so that is DFS dot name, the name node name which is running Hadoop 2.0. So with two different versions, two we can able to copy the files with the tool dist cp. Okay, see here I am running this command Hadoop. I'm going to create a directory first. This cp test. Okay, I am running the command now. Clear Hadoop. So run the command dist cp. Okay, now I want to copy the file from HDFS1. So write HDFS colon slash slash localhost colon 8020. Here the username is in the directory user Cloudera, and the username is Ajay, and I have a file. Right, cities 5.java. Cities 5.java. Right, I want to copy this file to the new HDFS colon slash slash localhost colon 8020 and user Cloudera, and the new directory I have created is dist cp test. Right, it's saying that invalid exception input source.
I guess that name of the file is wrong. It is IES maybe.
Yes, correct. Use right, localhost it's a user Cloudera CITIES. Right, so a map ready job is created. Right, files copied 1. Right, so generally we use distcp to copy the files between the clusters, right, between the name nodes. Now the file is copied to the directory new distcp test. We'll see here user Cloudera. Okay, the file cities5.java is copied to the directory distcp test. Now what I did with this distcp, I have copied the file cities5.java from the Ajay directory to distcp.test. Now after some time you have updated the source file, right? So when you updated the source file, now you want to make these updates into the destination file, then you can use Hadoop cp-p update and specify the source file name and the destination file name. Then only the updates will takes place in the destination file. Okay, suppose you can write Hadoop cp-p right, update. Okay, so if you have updated, first you have copied the files from Ajay to another directory. Now when you updated the source file, now when the source is updated, right, now you have to update the same file in the another name node, right? So to update the updates in the destination file, so we have to use the parameter -p update. So only the new updates will be updated into another name nodes file. Okay, so for that you have to use -p update. Okay, so this is one way we can able to copy the files from the one node to another node, one cluster to another cluster. Okay, and next we see this cube. Okay, uh, see this is a MySQL terminal. Clear show tables, right? So these are the tables which are available. Let me see. Select star from x1, right? So I'll create a new table. So I'm writing create table some x2 as select star from test1 x1,
One.
right? So now select star from x2, right? So these are the records which are available in the table x2, right? So this is MySQL terminal. Now if I want to get this data to HDFS, I want to import this data into the HDFS directory. So you can write the scoop import command to import the data from the MySQL to HDFS. Okay, so we have scoop. Okay, scoop is a component which is used to import the data between the HDFS and RDBMS. So in the scoop we have a command import. So using scoop import will import the records from the MySQL table to HDFS file system. So for this one you have to write the command scoop space import. So to import this I'm using JDBC connection. So I'm writing connect. So write the connection string. So I'm using JDBC. So I'm writing connecting JDBC colon MySQL colon slash slash localhost. Okay, so what is the database name? Select the database name, show databases, right? So I have a database name is test, use test. So here I am writing the database name test. Okay, so then specify what is the table name, right? Table. The table name is what? Show tables. The table name I am using x2. So write table name x2. Okay, I want to target into the I want to copy this data to a directory, so I'm writing target dir. So I want to copy this to the directory user cloudera, the directory name x2, right? I want to use one mapper hyphen m1, right? Username to connect to MySQL, the username is root. Okay, and right, the password is root, right? Generally we can end we can hide this password, that I will discuss those things in the scoop session. Right now I've run the command scoop import. So this is the connection string. So to the connection string, JDBC connection string, I'm going to connect to the MySQL which is configured in the my local host. Right, the table database name is the test. In the database test I have a table, the table name is x2. Now I want to get the records of x2 and I want to load these records of x2 into that HDFS directory in a table x2, right? So I want to use one mapper to get the data. So the username root and the password is root, which is used to connect to MySQL, right? So here see, take a terminal. So right,
So MySQL shall you separately,
sorry,
Ajay?
yeah,
This MySQL shall you have separately installed or how
yes,
it
I
is?
have
Suppose I'm
configured
using,
that one.
okay, I can connect with any database, SQL Server or anything,
Yes,
that
you
way you
can
just
connect.
have to
Yes,
mention.
yes, you can use Teradata, SQL Server, S2, any database. So we need a connector for that.
Okay.
Okay, so I'm writing scoop import. Okay, so what we have to write now, we have to write the connection string, that is connect. So what is the connection string? JDBC colon MySQL, right? JDBC colon MySQL colon slash slash localhost colon, right? Localhost, you have to write the database name test. Okay, scoop import space the connect to MySQL through JDBC, and the database name is test. Okay, and what is the table name? Right, the table name is x2. Right, so where I want to load this data, I want to load this data in HDFS directory. So write target hyphen dar, which directory I want to load this, in user Cloudera, and I want to create a directory with the name x2. Okay, so use one mapper hyphen m space one. So the username is root and password is root. Okay, see, retrieved 5 records. So I have wrote the statement. What is the target directory here? The target directory is user Cloudera x2. Right, the directory x2. Okay, so this is a part file. So these are the this is the data, these are the records which we have imported from the MySQL to HDFS file system. Okay, so it's copied as a part file. If you have the 3 mappers, 3 part files are going to be created. Right, so this is one way where we load the data into HDFS.
What is this mapper?
Sorry.
Mapper reduce. What is this
That's,
mapper?
yeah, that's we'll discuss in the map reduce. See how to collect that, how
And
many mapping process we are assigning. Right, so one map will go to the MySQL and it will retrieve. Suppose there are 1 lakh records are there. So one, if you specify hyphen m1, so one mapper is a one process will connect to MySQL, will retrieve all the 1 lakh records. Suppose if you specify the 4 mappers, okay, then so 4 mappers goes to MySQL. So mapper 1 will retrieve 1 to 25,000, mapper 2 will retrieve 25,000 to 50,000 records, mapper 3 will retrieve 50 to 75,000 records, mapper 4 will retrieve 75,000 to 1 lakh records. So 4 mappers will work simultaneously, which will retrieve all the 1 lakh records in the same time. Okay, and four part files are going to be created. Okay, so in this way, so you can retrieve 1 lakh records with the time, in one same time. Right, how right, it takes very much little amount of time. Right, so if you have configured multiple mappers. Okay, right, so we can able to see
okay.
that Hadoop FS cat with the command cat, you can write user Cloudera and the directory name is x2. The file name is part hyphen m hyphen. Okay, so these are the records which we have loaded into HDFS. Okay, right? Next we'll see CP. Alright, now we are using the file browser. Okay, see here. Now see, I have a hue configured. So here I have this one, right? See, these are the directories in HDFS. Okay, now in the directory Ajay, so these are the files which I'm having. What I'll do, let me take some test file, edited. Okay, I'm writing some right Hyderabad, Bangalore, some Chennai, right? Right, I'm saving this file in my documents as visitors, right? So this some file is available in my documents, right? So what I'll do, so in HDFS, see, this is a file browser. In user Cloudera, I have a directory Ajay. Now here I am selecting upload, select the option files, select the file. Now from the documents, right? So select the file visitors, click the button, okay. Right, now the file is uploaded into HDFS in the directory Ajay, right, where you can see the visitors. Okay, see here, user Cloudera and Ajay visitors. Okay, so this is one way we upload the data into HDFS, right? Once the data is available in HDFS, you can use Hive, something like this, create table visitors, right? We have cities as a string. You can run this command. Okay, table is created, right? Create table visitors, the table is created, available. Now load the data, load data in path where it is available. It's available in user Cloudera, in the directory Ajay. The file name is visitors, right? I want to load this into the table visitors, execute this. Right, the file name is VISTORS. Okay, string. The file name is VISTORS. Okay, into table visitors, execute this. It is taking
Cloudera, Cloudera spelling.
ACLO, right?
A caps, Ajay.
Set load
Hue is configured in this VM which you have given us.
in path. The second user load era and Ajay visitors into table starts. Okay, right? So it's successfully inside the records. See the history, right? Available now,
Ajay,
right? Yes. Select start from visitors. Okay, right? So this is we have loaded the data from the local file system to HDFS file system, from HDFS to Hive table, right? So this
Ajay.
is one way. Yes.
Hue is configured in the VM which you have given us.
No, I have not given you the hue, right? I have given without GUI.
Okay, then just please show me that first part again, that not the querying part. In Hue, like manually how you do through web browser something you showed, right?
This one query editor we have in the hue. So select this
Query
one.
editor I got to know, the other one. First something you showed, right?
Yeah, it's a file
Okay.
browser. See, this is file
File
browser
browser.
to load the data. Suppose if you want to create a directory or you want to copy a file, you want to delete a file, you can able to do, right? Suppose you can create a directory, new directory. I'm giving the name Srijit. Create, okay, right? Directory Srijit is created. Now, if you want to copy a file, so instead of Hadoop FSF and put, you can use this one. Select files, right? You select any file, open, right? Now the file is uploaded. Okay, it's a tab browser, file browser. Okay, so this is one way we load the data into HDFS. Apart from that one, you can use FTP, like you can use SSH telnet or login to connect to the right Hadoop, and you can able to copy the file. See, you can use SCP, right? So you can use this WinSCP to copy the file. Is one way we can copy the file from the local file system to, will directly copy the file onto the HDFS. Okay, right? So these are the different ways we can write a Java program to write the data into HDFS.